Yes, welcome back to BakoMaths, and today's lesson we'll be looking at how to solve systems of linear equations using the Gauss-Jordan elimination procedure. And so if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we start with the systems of linear equations. So to solve the systems of linear equations, we first have to augment matrices for the systems of linear equations. And so you can write here as augmented matrix. Now the coefficient of x1 in the first equation is 1, in the second equation is 1, in the third equation is 0. The coefficient of x2 in the first equation is 2, in the second equation is 1, in the third equation is 1. The coefficient of x3 in the first equation is 3, in the second equation is 2, in the third equation is 2, and we bring our constant, that is 6, 4, 8. Now our main focus is to change this augmented matrix to the reduced row echelon form, and that is of the nature 1 0 0 0 1 0, and we have 0 0 1, and then we may have some other constant terms here. Now at the end, these constant terms may be the values of x1, x2, and x3, and so we proceed by rewriting our augmented matrix at this side. That is 1 2 3, and we have 6, and then we have 1 1 2 4 0 1 2 8, and we close it. Now comparing the augmented matrix to the reduced row echelon form, we can see that the first non-zero entry in row 1 is 1, so as to the augmented matrix. Now in the reduced row echelon form, we can see the first entry in row 2 is 0, and so we have to make the first entry in row 2 in the augmented matrix to be 0. That is, we want to make this one 0 by first considering the pivots in row 1. And so since that effect is going to happen in row 2, we can write here as row 2 is equal to. Now how do we make this side 0? So to get the formula, then we can do this simple illustration. And so we are considering row 1 and row 2 itself. You can see the first element in row 1 is 1, and that of row 1, row 2 is also 1. So what must we do so that these two elements goes to 0? Simply, if you subtract and then we add them together, you are going to get 0. And so our formula now becomes minus row 1 plus row 2. So let's simply write it as minus row 1 plus row 2. And we continue for the rest of the elements. And so in row 1, the next element is 2. We write 2, and we subtract, and row 2 is 1. And so we have here as minus 2 plus 1 is equal to minus 1. And then the next element in row 1 is minus 3. Is 3, but we bring our minus, so it becomes minus 3. And then row 2 is 2. And so we have minus 3 plus 2 is equal to minus 1. Now the next element is 6. We bring our minus, and then in row 2 we have 4. And at the end we are getting minus 6 plus 4. That gives us minus 2. And so this becomes a new element for row 2. And so we can write our new matrix as 1 2 3 6. Now we maintain the same values for row 1 and row 3 since the effect did not happen at those rows. And row 2 now we have 0, minus 1, and we have minus 2. And for row 3, maintain the same values, that is 0, 1, 2, 8. Now our next step is to change this minus 1 to 1. And so we can do that by simply multiplying the whole of row 2 by negative row 2. And at the end, we are going to get this 1 to be 1. That is our focus. And so we continue by rewriting our new matrix of this form. So we maintain the same values for row 1 and row 3, and that becomes 1, 2, 3. We have here 6. And so row 2 now becomes 0, 1, 1, 2. And maintain the same values for row 3, that is 0, 1, 2, 8. Now our next focus is the fact that we want to make this one 0. We want to make this one in row 3 0. We can do that by considering the pivot in row 2. And so since the effect is going to happen in row 3, let's write row 3 is equal to, basically to get the formula for easy calculations, let's write here as row 2, since that is what we are considering, and row 3 itself. And so the first element in row 2 and row 3, they are 0, 0. And when we sum 0, we are going to get 0. Now the next step is for us to consider the 1 in row 2 and the 1 in row 3. And so what must we do so that these two elements goes to 0? Basically, if we subtract and then we add the two together, we are going to get 0. And that becomes minus row 2 plus row 3. And so our formula now becomes minus row 2 plus row 3. And so consider for the rest of the elements in row 2, we have 1. We are subtracting. And so we bring it. And in row 3, we have 2. And so when added, you have minus 1 plus 2, we have 1. And in row 2, we have 2. We subtract, and in row 3, we have 8. And so 8 addition gives us minus 2 plus 8. That gives us plus 6. Now we continue. So at this point, we are going to rewrite the new values for row 3. And that becomes, since the effect did not happen in row 1 and 2, maintain the same values, that becomes 1, 2, 3, and we have 6. And in row 2, we have 0, 1, 1, 2, and row 3 now becomes 0, 0, 1, 6. And so our next step is for us to change this minus 2 in row 1 to 0. So we can change this 2 in row 1 to 0 by considering the pivot in row 2. And so since the effect is going to happen in row 1, let's write row 1 is equal to, how do we get it? Now we continue with our simple illustration, and with that, it becomes so easy for us to proceed with our calculations. And so we consider that, and we have here, we are considering row 2 and row 1. Now the first element in row 2 is 0, and in row 1, 2, I think it's 1. But that may not be our focus. Our focus is to change this 2 to 0. And with that, we have to look at how the formula is going to make these two elements in order to change this 2 to 0 before we apply to the first element we see in row 1 and row 2. And so we can write in row 2 as 1 and in row 1 as 2. And so we ask ourselves, what must we do so that these two elements, when added, goes to 0? Simply, when we multiply this side by 2 and we subtract, then it means we are going to get minus 2 plus 2 to be equal to 0. And so our formula now becomes minus 2 row 2 plus row 1. So you have here minus 2 row 2 plus row 1. And so we apply the same formula to the first element. So at this point, we are multiplying row 2 by negative 2, and we add to row 1. That becomes 0 plus 1, and we are getting 1. We apply the same formula for the rest of the elements, and row 2, we know here to be 1. Now multiply is minus 2, and in row 1, we have here to be 3. And so when we add, we are going to get minus 2 plus 3. That gives us 1. And it continues for row 2 and row 2. We have the next element to be 2. So we have 2 multiplied by minus 2. And in row 1, we have 6. And so at the end, we are getting minus 4 plus 6. That gives us minus 2. And this becomes the new element for row 1. And so we can write our new matrix as. So in row 1 now, we have 1, 0, 1, and we have 2. And row 2, we maintain the same values, 0, 1, 1, 2. And row 3, we have 0, 0, 1, 6. Now, having done this, we want to change this one to 0, and also change this one to 0. But let's take it one after the other. And so our focus is to change this one to 0 by considering the pivot in row 3. And so since the effect is going to happen in row 2, let's write here as row 2. Now, how do we get the formula? We can get it by simply considering. So write here as row 3. And we are considering row 2 as well. And so, you know, the first element, they are 0, 0, 0, 1, 1, 1. But then our focus to change this 1 and 1 to 0. So since that is the third element in the matrix, so we can write them at the bottom. So we have 1 and 1. And so what must we do so that these two elements when added goes to 0? Simply, if we subtract from row 3 and we add to row 2, then we are going to get minus 1 plus 1. That gives us 0. And so the formula now becomes minus row 3 plus row 2. And so you can write here as minus row 3 plus row 2. And so we are going to look at how the formula is going to be used with the rest of the other elements. And so the first element is 0. For row 3 is 0. So you write 0. And in row 2 is 0. And so when we subtract at the end, we are going to get 0. And we continue for row 3. We have here to be 0. We are subtracting in row 2. We have 1. And so when we add these two elements, basically we are going to get 1. Now the third element is what we have done. That helps us to generate the formula because that is the focus. And so we continue for row 3 and we have here to be 6. And since we are subtracting, we bring it. And for row 2, we have here to be 2. And at the end, we are getting minus 6 plus 2. That gives us an answer of minus 4. Now we continue. And then at this point, we can see that this element becomes the new row for row 2 now. And so we can write our new matrix as. So since the effect not happen in row 1 and row 3, we maintain the same value. So we have here 1, 0, 1, 2. And for row 2 now, we have 0, 1, 0, minus 4. And for row 3, we have 0, 0, 1, 6. Now, what is our next focus? Our next focus is for us to change this 1 to 0 by considering the same pivots in row 3. And so, since the effect is going to happen in row 1, then let's write it as row 1 is equal to. Now, how do we get the formula? We can do it, or we can get it by simply doing our normal illustration. And I think that is the easiest way for us to get it. And so, we write here as row 3 and row 1. And so, these are the third elements for the rows in the matrix, and so we can write them as at this side. And so we simply ask ourselves, what must we do so that these two elements when added goes to 0? Simply when we subtract from row 3 and we add, then we are going to get 0. And so we have minus 1 plus 1 is equal to 0. And so our formula now so minus row 3 plus row 1. And so we can write our formula as minus row 3 plus row 1. And so we are going to see how the formula is applicable to the first element in the matrix. And so the first element in row 3 is 0. And when you write 0 here, and even if you subtract the same 0, and row 1 is 1. And so when added, we get minus 0 plus 1 is the same as 1. Now we come to the next element, that is 0. So minus 0 is 0, and row 1 is 0. And so when we add, we are going to get 0. And the next element is 1. That's what we use to generate the formula, and we have done that already. And we continue with the next element, that is 6 in row 3. Remember, we are subtracting, and row 1 is 2. And so when added, we have minus 6 plus 2, and that gives an answer of minus 4. And so these are the new elements for row 1. And so you can write our new matrix as. And at this point, we have 1, 0, 0, and we have the next element as minus 4. We maintain the same values for row 2 and row 3. That becomes 0, 1, 0, minus 4. And we have here 0, 0, 1, 6. And so with this, it means that we have been able to change the augmented matrix, remember, to the reduced row echelon form we talked about earlier. And here's the case. We can find the values of the variables x1, x2, and x3. Remember, these were columns of x1, and this was columns of x2, and this one, they are columns of x3. Remember, these are the constants. And so if that is the case, then we can say that by back substitution, then we can say that now x1 multiplies 1, we have x1, and x2 multiplies 0 is 0, x3 multiplies 0 is 0. What is left the constant? So it means x1 is equal to minus 4. x1 multiplies 0 is 0. x2 multiplies 1 is x2. x3 multiplies 0 is 0. What is left the constant? So we have minus 4. Now x1 multiplies 0 is 0. x2 multiplies 0 is 0. x3 multiplies 1 is x3. So we have x3 to be equal to 6. And this becomes the values of the variables x1, x2, and x3. And so this ends today's video. Thanks for watching. Kindly like, comment, subscribe, and share. BakoMaths, thinking beyond infinity.